Hello everyone, this is Katish here. In this video, I'm going to go through the AQA chemistry paper from 2022, paper 1, higher tier. Question number 3 is on the topic of bonding structure and the properties of matter. This question is about different forms of carbon. Now, remember, different forms of carbon of any element is generally known as allotropes. Figure 5 represents the structure of diamond. How do you know a diamond? It has this pyramid structure generally, and it's just made up of carbon. Silicon oxide also has a similar structure, but it's made of silicon and oxygen. So it has a diamond structure. When I say diamond structure, I'm referring to this. Right. Describe the structure and bonding of diamond. Now, for 3 marks, they're actually asking 2 questions. They're asking about the structure first and then the bonding as well. So you need to describe both of them. The structure, it has a giant covalent structure with covalent bonds, and there's 4 carbon atoms per carbon atom. Those are your 3 points. So if a giant covalent structure, or you could say giant structure, giant covalent bonds, 4 carbon atoms per carbon atom. You just bring it to one line, I think it'll be easier. There you go. Just as a quick note, in comparison to diamond and graphite, here's a little bit of notes. Remember, graphite has this hexagonal carbon ring, and it forms layers, and there's weak forces of attraction between the carbon atom layers, and each carbon is bonded to just 3 other carbon atoms. Explain why diamond has a very high melting point. Now, melting point is linked to the bonds, the type of bonding, and the amount of bonding, and the amount of energy that is needed. So covalent bonds are strong, and many covalent bonds must be broken, so a lot of energy is required in diamond. Figure 6 represents the molecule C17. Now, C17 is just made up of carbon. It looks like a ball, and you could call it a fullerene or buckyball, and it forms these hexagonal patterns, and each carbon is bonded to 3 other carbon. That means there's a free electron. That means it can actually conduct electricity as well. So what is the name of this type of molecule? It's called fullerene. Now, graphene nanotube and are also allotropes of carbon. So just to give you as a note, this is what fullerene nanotubes and graphene look like. Remember, polymer is a long chain of carbon molecule, but doesn't have to just have carbon. It contains other elements as well, but it has a carbon backbone. Molecules such as C70 can be used in medicine to move drugs around the body. Suggest one reason why the C70 molecule is suitable for this use. Now, C70 is like a ball structure, so it's hollow, so there's space inside it, and because it's carbon, it's not toxic, and it wouldn't actually react, and because of its size, it should have a large surface area to volume ratio as well. So any of these points is valid. C70 is hollow, C70 is unreactive, C70 is not toxic, and C70 has a large surface area to volume ratio. Calculate the number of C70 molecules that can be made from 1 mole of carbon atoms. Now, the Avogadro constant is 6.02 times 10 to the power 23 per mole, which means in 1 mole, that's 6.02 times 10 to the power 23 atoms. Now they want to know the number of carbon C70 molecules. So each molecule has 70 carbon atoms. That's why it's C70. So if I divide 1 mole by 70, that would give me 0.0142857 molecule. Or molecules. Now that has like a fraction of 1 mole. So that is the fraction of 1 mole. If 1 mole is that many atoms, how many is this? So all I have to do is multiply this number, 0.0142857 times 6.02 times 10 to the power 23. That would give me an answer of 8.6 times 10 to the power 21 molecules. That brings us to the end of question number 3, and I will see you in question number